Hey Cliff, how are you doing?
Hi. Fine.
Fine. Okay, then what was your first computer?
My first computer.
Hmm.
Um, Holy crap. First one I remember I got when I was, I don't know, 10, 12. I guess the first one was actually I got to fool with a Xerox mainframe as a kid. Mom worked at the University of Sangamon State, Illinois, and they had a Xerox mainframe. And as a kid, whatever faculty they let me in and write punch cards and simple little programs and games. They're all done with punch cards from printouts.
And I never heard about the Xerox mainframe.
Yeah, I mean, Xerox was doing mainframes at roughly the same era IBM was doing their starting mainframes. Xerox eventually bowed out of that market, but yeah, Xerox did mainframes.
Okay,
Spinning tape drives and punch cards and a whole 9 yards.
okay. And and you as a kid, you wanted to program or play, or why you did with the mainframe something at all? Because it was complicated, right?
Um, so separate things. So I was these days I would have been diagnosed somewhere on the spectrum between autism and Asperger's, kind of somewhere in there. And back then, I was just super geeky, super shy, super socially bad kid who was really good with science and math. And I was judged too small to go to high school, having passed middle school with straight A's. So I retook the eighth grade at middle school, having passed the straight A's the year before.
Okay.
As they thought I'd be too little to be in high school. So my math teacher was like, "What the hell are you doing here? You know this shit." So she gave me a Fortran 4 book. So I thought that was really cool. So I read it and understood what was going on. Thought that was kind of fun, and so I hand toyed with writing little hand programs and running them in my head and whatever. And I got a Bell Labs bug computer. I have to go find the thing now. It's a totally cardboard paper computer.
Hmm.
Some that era as well, and messed around. Thought these things were kind of cool. So somewhere in there, my mom decided I could go to Sangamon State with her and the university during the summer and fiddle around with Fortran for real. So that worked out well for me. I mean, I liked what I was doing. I was all kid stuff, toy games, and print out a calendar or make pictures on the printer or count from all the primes from 1 to 100 and stuff like that. As for being complicated, it was Fortran, and the operators thought it was cool, I guess, to have a 10-year-old kid, 10-year-old kid, and so they gave me the necessary JCL cards, and I just stuffed my Fortran in the middle and ran it through the card deck, and out came my printouts, and I was all super excited. And I ran back and fooled around, and changed the cards, and ran it again, and it's all good. So yeah, I was programming on a mainframe when I was 9, 10.
What you did? I mean, which programs you wrote?
Well, it's Fortran, so whatever you can write in a Fortran program. So, like I said, I wrote a program to like sieve a vertices and discover the primes from 1 to 100.
Hmm.
I started out with things like I just write anything, do a print statement, and have it print 1 to 10 and
Hmm.
1 to 100 and table of squares, and get alignment because it's got 1, 2, and 3-digit numbers, and you have to screw around with alignment to get it to be nice and tabular on your piece of paper when it prints out. Big picture printouts that were just a series of print statements in a row, a game of NIM that each turn required you to change your move as an input to the program. That would, it's an African stone game. But there's a very simple strategy that I could teach the computer, and then he would play back and forth, but you had to go through the punch cards and the printout to each turn, that kind of stuff. So that was, summer for me. Not long after I got hands on a super tiny microcomputer, I went to summer program the next summer at West Valley. Gosh, there goes senior now. What the hell? What's the name of the school for cadets in the East Coast? That's the famous Army school.
I only know Top Gun.
No, there you go. No, it's not that
West
one.
Point.
West Point predates Top Gun by quite a
Okay.
while. Yeah, they had a summer school. They were trying to get people excited, military recruits excited. I was, excitable, but I was too small. But I had fun in the course. It was some amount of physical stuff, some amount of learning about this and that, and some amount of math and science. There was a lot of math and science that was interesting to the military, like logistics things. Um, Fine. I learned. I was good at it. It was all good. Uh, Back home, 1 year later,
You were at military school?
for summer class. Yeah.
Oh, interesting. As kid.
Yeah.
Okay,
Yes.
that's interesting.
Just summer. It's like summer program. I mean, I did summer programs where I went to Scottish Arts and I learned to play the bagpipe, and summer school at West Point, and learned some amount of like I said, math and science bits. Some related to weapon handling and guns, and some related to, like I said, logistics and supply chain things. Some related to this newfangled computer stuff, and I was, I can do the computer thing. So we built a little tiny microprocessor on a board with a display, little hexadecimal display, hexadecimal keyboard, and I can solder. Okay, so I put this thing together. It's kind of fun. Then I wrote little games on it, and it was an RCA 1602 or something, little tiny microcontroller. At that era, the chip was as big as my thumb, and had 8 registers and 20, 30 ops, and did some very simple stuff. And it was a microcontroller. Not long after, I want to say I was 13 or 14, I got my hands on a Radio Shack Trash 80, KRS 80. So Z had BASIC. I programmed a bunch of games in BASIC. I did stuff with my brother, doing whatever things, simulations for vehicles driving around, and games like a classic hexagonal board-shaped board games where you would do war units and you would take turns moving units back and forth. And I had the computer doing its half of the movements and stuff.
Were you fast programming the games, or you struggled? Or I mean, because it's unusual, So you wrote lots of apps or programs.
There were no apps at that era. No apps.
No apps. It's my kind of, right. So I mean,
no programs. You didn't buy any programs. You wrote them.
Yeah, sure. I remember also these days. I started with static spectrums. I also had to do the same thing. So I wrote programs. And
okay.
But what's interesting, you said you read the Fortran book.
Yeah.
And you immediately understood it, or I mean.
Yeah.
But how it's possible? You were, you read, the concepts, and you knew what's going on, or I mean, because this is unusual, right?
Okay. Yes, many things about my life are unusual, and they're all normal to me because that's what there was. I just did it and didn't think anything of it. And then I come find later, when I get a little more socially aware, oh, you can't do this too? Why not? It's easy. I can't say, anything more about it. Now I would look back and say, oh, sure, that's wildly crazy. And of course, as a parent, I'd push it hard because the kid's doing this amazing thing. So why the hell not push it and see what happens, right? Yeah, I read a Fortran book. It all made sense. What the hell? I don't know. You're like, hey, this is weird. Okay, it is. That's not the only weird thing about me.
No, what interests me, if you read that concept, let's say a for loop or if statement or whatever, you were able to visualize it, or you were excited and knew how I can apply it, because understanding with.
Yeah.
I mean, what can happen is you read the book and it's boring and you understand it, but you don't know what's going on. You know what I mean? So it's interesting to me how you understood the structure and the book.
It made more sense when I sit down at the terminal at the Xerox mainframe and started going back and forth. And there were times I didn't understand, and I'd ask help from people, and they were busy, or they did, or they didn't, and then they helped or not according to their whim. But yeah, the basic concepts came really quick on for loops and variables and stuff. The machines were simpler back then, so you just you built a model in your head. I have a variable; it counts up 1, 2, 3. I have a for loop; it counts up to the top number. I have an array; it's got a bunch of storage elements, one after another. I can pick which one I'm picking on.
Okay.
Once you pick each concept, the next one builds pretty quick. Whatever. That was it. You had memory, you had a loop, you had some variables, control flow tests. that was all of it, and now I can write a thing that computes primes.
Mm-hmm. And why you were excited? You wanted to do more with the computer or program a specific game, or what was your goal, or you just were general?
I have fun. I'm a kid.
Okay.
This is a thing. Oh, look at this thing I can do. Oh, look at this thing. Oh, it makes the parents, the adults, look kind of wild. But even then, I wasn't doing it for the adults. I was doing it because it was kind of a cool thing. I had power over the world in that I could make something happen with this thing.
Okay. Mm-hmm.
You flip a light switch, light comes on. Well, after a while, it gets boring. It's too simple.
Mm-hmm.
But I am doing more complicated things, and I'm building something,
mm-hmm.
and I get the sense that I'm building something and making something happen.
Yeah.
So you got a pile of Legos. You build a house. You build a farm. You build a robot. You build a ship. You build a spaceship. It's all in your imagination, but you're building and you're having a sense of accomplishment.
Mm-hmm.
Here I am building, but I get some immediate feedback. Okay, cool.
Yeah, very cool actually. So I was always interested to know what's the motivations are. If someone start programming.
Whatever motivation a 10-year-old has.
Yeah.
Go have fun.
Okay.
What's fun? Well, okay, that varies by kid. I was not social. People were kind of dangerous. I didn't understand them very well. So.
But okay. But now you are very social, so it's changed a lot, right?
Very, very different. I have very carefully, in autism, you call it masking. Super good masking. I very intellectualized how to have conversations with people, and then no one tells I'm masking. Okay. But I know I'm masking, and if I tell you you're masking, you'll know it, but you won't know you'll tell me not masking. So I don't know. It's fine. And I have a social budget, and it runs out, and I'm done, and I go do mini solo things with nobody around, and that's all happy, and I recharge my social hours. But I'm good for a couple hours a week tops, full time. That's part of being on the spectrum. It's fine.
Okay, perfect. So you were at West Point. You enjoyed that, so you learned, and you even find more that you learn programming. And then you had the trash, right? There was the TRS.
TRS 80, yeah, commonly called Trash 80.
Trash 80.
Yeah, and then from the Trash 80. I wrote a bunch of basic programs because it came with basic. And then I wanted to do assembly. I had done machine code on this little RCA Cosmac. I had done, lower level coding stuff also on the mainframe.
Mm-hmm.
Looked at, abend, abort end, whatever, crash dumps. What the hell is this pile of hex digits? Well, that's the machine code for the generated program. What's this mean? Well, I got a IBM 360 manual. They had the same instruction set as an IBM 360 because that was they were making cheaper mainframes for IBM, whatever. Fine. So I knew what machine code was. I started looking at the Z80 thing. I started trying to decipher that. I wrote a little tiny peek poke disassembler. It wasn't very good. I got a better one. It was too hard to use. I went back to my cheap one and made it get more robust, and I could poke memory and write code in it. So pretty soon I was writing Z80 assembly code. And then
still for fun. Still for fun. You wanted just to write assembly without any
Yeah.
Okay.
Right. What can I do here? This is a crazy thing. Let me do things. How does this basic thing work? What the hell's the magic trick with basic?
Mm-hmm.
It does a cool thing. It has variables. It has line numbers and go-tos. It has these high-level statement expressions. How the hell does it work? How the hell the Fortran compiler do expression things?
Mm-hmm.
What's going on here? So I got the Byte magazine. It had the Pascal. You can find them still online and whatever the archives. The Byte magazine Pascal syntax tree. So it's railroad track DNF diagrams and a discussion about generating P codes. And then I knew I could look at the P codes. I could write a basic program to execute P codes. So I sat down, wrote a basic. In basic, I wrote the Pascal parser to produce P codes. And that was, most of the memory on the box. So I couldn't actually run the P codes that I generated, but I had to write a Pascal program. So I wrote a Pascal program to do a breakout game. So, I don't know, the old school breakout games, you have a paddle at the bottom, moves back and forth, and you have a bunch of blocks. The ball bounces around off walls. I did a lot of ball bouncing things. As soon as I had graphics on my hand, I had ball bouncing things.
How you call the game?
It's called Breakout.
Breakout. Arkanoid, I think this is my...
Arkanoid owned... Yeah. Somebody had the rights eventually. A bunch of people were doing breakout games. Somebody ended up with some name or rights or whatever.
Okay.
I wrote a breakout game. Clone. I eventually added sound. I didn't have any color. It was a Trash 80. So there wasn't any color on it. But I had sound. I had a score on it eventually. Otherwise it would just it was a skill game, bounce the ball until you missed, and then the ball left, and then immediately another ball can, and then change that to, there's things to hit. Oh, they go away when they get hit. And then, you build up gradually, you build a game. So games are very interactive. It's a lot of fun. My brother liked it. The neighbors liked the kid. Oh, look, Cliff's got a breakout game. We'll go play the game. Fine. That made me feel really good. Somebody's playing my game. It wasn't just me. And then that was in Pascal. And so to get from writing the game to running it, I had to write a P code interpreter. Which was a P code translator. It actually just translated P code to Z80. And then I would run the breakout game that way. So somewhere around age 15, I wrote my first compiler because I was very interested in how these tools worked. How did this Fortran compiler work? How does BASIC work? And realized it was way the hell faster in the generated code, and I could do things you couldn't do in the language, which wrapped bumpers around you so you keep you in the safe zone for the language, but that meant you couldn't do a bunch of these other things like cool graphics hacks when you poke the graphics card directly. And things just kind of kept ramping up, but that was my natural inclination. More summer school, more hacks. I got on a Trash 80, not the Trash 80, next one, a color computer, Radio Shack color computer, had color now. And I got a lot more aggressive with doing fun things with that, and more real-timey game stuff, and back to compiler code generation things. I'm going to Forth. Forth is world's first self-modifying programming language. I don't know. It's a very easy to write, easy to use thing. Not a whole lot of bumpers to save you from bumping yourself to death, but it's very easy to write them, and then immediately you can get interesting performance out and write new things because it peeks and pokes the raw hardware all the time. It's actually, Forth to this day is still kind of commonly used for doing very early startup on new chips.
Yeah, and Sun, I wanted to say, right? The Sun's workstations, they use Forth as a bootloader or something.
Yeah, right. And that's not the only people that do that. It's a common, easy hack to get started. Basically, if you've done it a few times, you can write a Forth in an afternoon. And I did, in fact, in college, write Forth for a new chip in an afternoon. And the prof for the class didn't know what to do with me, so he told me to stick around, show up at classes, and just give me an A and get out of here.
And you were good at school entire time, right? So you... Yeah.
If it was anything to do with computers, I was good at it.
Okay.
So, I went to an engineering degree. Thermodynamics engineering. I had to take electrical engineering. I had to do thermodynamics. There wasn't no computer science class then. There wasn't no computer science course. So I took electrical engineering. Well, I had to take thermodynamics. That almost killed me. I had to take math up through partial differential equations. That almost killed me. Computers, piece of cake. Walk in the park.
Math killed you. I thought you were good at math back then, but then you lost somehow the inspiration, or...
On math, there was just a limit to what I cared for. Later, I picked up more math and new teaching technologies. So, I did startups where I did a bunch of math and a lot of conversations as a 50-year-old guy with the Stanford triple math professors set up. Started doing big data and math, and I was having to parallelize and distribute big data doing big math algorithms. And the big math algorithms had to be distributed, and a lot of them hadn't been distributed before, and that's a non-trivial to do it efficiently and whatever. That was a lot more math understanding I picked up much later in life. 15, 16, 18, 20. Math up through partial differential equations, that was tough. Calculus was fine. Calculus was at high school level, very rules-based. And I rules and manipulate them in my head, symbology-wise, sort of easily, fast. So I kind of blew through calculus like nothing going on. As soon as I understand what the rule was, I could reshuffle them in my head for free. And I sat in front of the class, and I would fiddle and do other things and do homework for other classes. And the teacher would ask me a question, and I'd go up and write the answer. And she, how do you derive it? Well, you just, one step in my head went from here to here. No, put some more steps in there. And I'd have to invent steps that I wasn't doing because she wanted to see my steps. But in my head, it was just like, ding, ding, done. And she was like, no, you had to do some other things. And I did. Oh, I just saw this went to here to there. It was all, my head would just wrap symbols and manipulate them freely. And that's what it was. So same with writing this code for the Trash 80, writing this Pascal compiler, it was all symbols in your head. And I always could take all those symbol things in my head and just visualize, manipulate, freely move around and immediately see the underlying math thing.
So you are
So
natural born compiler, right? So it seems like.
yeah, well, rules manipulation. It didn't have to be compilers.
Mm-hmm.
That's what I got famous for, but I did other things. Like I said, the calculus, the same rules.
Mm-hmm.
There are other places where these kind of games can be played. And in all of them, if there's some sort of abstract symbology I can put in my head, I can go to town on it, manipulate it all to hell, and do all kind of fun things.
So you enjoy abstractions, I guess, right?
It comes out, yeah.
Mm-hmm.
Yeah, there's some kind of abstract thing going on there.
Just like it is a symbol, then you replace with another symbol, and you enjoy just thinking,
juggling around, and manipulating. So I tell people if they ask kind of what I do at that level, I tell them I do maths and logics.
Mm-hmm.
I play with math systems and logic systems in my head. I don't know. Compilers are a big piece of that falls right in that camp.
Mm-hmm.
So I don't know. You want more history?
Yeah, absolutely. So it is more interesting than I thought because yeah, and
right. What the hell are you gonna do? So somewhere in there, let's see. I went to college first year. I needed a summer job. Hughes Tools. How did I get connected with Hughes Tools? Somebody had heard of me, connected me, and I'm 17 or 18. I'm just out of college,
mm-hmm.
first year, and they're a union shop doing oil. Big oil in Houston. So big oil, big money, big whatever. They have an IBM mini computer, AS400. They got a contractor that had been working on it, had done them an accounting system. He was gone. They wanted somebody to carry them through for the summer. I got paid union rate to babysit an AS400, which was mostly working fine. So it didn't take me,
mm-hmm.
any time. Holy crap. I was like, wow, I'm making really good money doing this shit. And I'm not doing anything. And then came month in, and there was some error in the accounting, and we kind of had to figure out what the hell's going on. They had some wrong records, and I got to stare at the records and looked at the database. What's going on there? It's a very primitive database, and there's some test things in here that look like they shouldn't belong, and the guy left some junk lying around the month-end database. So I had to go clean that out, and then I had to rerun the month-end accounting, and then I had to go sort the how do I exclude these records from happening again, and that took me most of the weekend. And I was, what am I doing? I'm 18. What else am I doing on a weekend? Go play arcade. Fuck, I'll go fix these people's problems. They've been very nice to me. I'm playing card games with them at lunch, and otherwise I'm just bored as hell. There's nothing going on. So of course I spend my time. Well, it's a union shop. You work the weekend, you get time and a half. Fuck, I got paid a butt ton of money. This was great. I fixed their problem. Monday they had the new accounting run, and they got their paychecks went out, and everyone was happy. Well, middle of summer, they got a quarter in, same bug. But they had a different program, needed the same fix up on for the quarter end versus month end or the year end, whatever. So another round of accounting went through. And I spent all weekend and half of another day sorting it, but I finally got it all sorted out. And they were like, weekend, time and a half, overtime and something else, holiday. I got triple time on already great union rates as an 18-year-old kid. I was like, holy crap, I'm running into the money. So that was if I was worried about being a computer geek before, I wasn't now. There's money here. Fine. The accounting ladies are all very happy with me. The manager was like, I can't believe we're living with an 18-year-old who's saving our ass, but he saved our ass. The worker guys are big, tough, buff, rounders and, guys that tear apart oil rigs and whatever.
Was it RPG, I guess, right? Was RPG programming language? RPG?
That was RPG, yeah.
And DB2.
RPG too.
And DB2. DB2 database? DB2?
There was some other way I was talking with. No, RPG had a direct connection to the database.
Yeah.
I got database records directly out of it.
Mm-hmm. But it was what?
I did write DPT2.
Mm-hmm.
I did RPG2.
Okay.
But that's the right era for that kind of thing, yes. Mm-hmm. And I just hacked their accounting program to exclude the test records the guy had left behind. So I never got where I actually manipulated the database, but I recognized the records that he had written that were not part of the normal accounting process.
Mm-hmm.
So,
but you had to learn RPG, right? So you learned the syntax. It was enough. Okay.
So I learned the syntax of RPG, and then having learned the syntax of RPG, I went ahead and programmed a game in it. So I had a Star Trek game that did printed out the quads and sectors. There was a galaxy. There was a 8x8 sectors that you get on a teletype printout that had your ship was one symbol and empty spaces for others and stars and planets and Klingons and Romulans and whatever things were going on. Yeah. What am I doing here? This is where I'm spending my summer.
And managers enjoy that, playing the game, I guess, right?
Yeah, sure. I'm building something cool. Wow, you can do this thing. Look at this. People thought it was cool. I got some positive feedback. And then, of course, I did the whole accounting rescue thing. Like, oh, there goes my mic. Mm-hmm. The cat has messed with me. Hang on a second here. Messed with the setup. So maybe it was, in fact, the case that the sound was bad because, mm-hmm. Catatonic, cat attack, whatever you want to call it, catastrophe.
Catastrophe.
Yeah. Mm-hmm. Fine. RPG 2, 18. Yeah, somewhere around 19 and 20, I got hooked in to do next summer, do a thing where I was doing PostScript clone for laser printer that was a competitor. It predated Apple's laser printer, but the laser writer came along and people were all excited about laser printers. And this was a high resolution, early cut laser printer. They wanted PostScript. So PostScript looked like fourth to somebody. So this math guy who was always a startup investor knew about me and my computer math skills. So he decided I had great math up until partial differential equations. So he grabbed me and a friend of mine and said, "Hey, I'll pay you guys and do a fourth. I know you do fourth. I know PostScript looks like fourth. I know you hack computers really big. Can you do a PostScript clone?" And I was like, I looked at the spec on PostScript. I'm like, yeah, sure, I can do this. So me and a guy named Paul Snow sat down and wrote a PostScript clone in fourth. And then while I'm hacking fourth, I'm realizing it needs some more love in terms of user interface and GUI. And I had seen Turbo Pascal at some point. So I did an IDE in fourth that gave you a graphical interface over a fourth language that had a namespace and had a bunch of other add-ons that fourth didn't normally come with that let you develop a larger fourth program sort of more directly. And that went over a course of 2 years. Eventually, the summer following or the one after that, we went up to Minnesota where the printing company was, and we spent the summer up there finishing the job and getting it embedded on the chips. Had to go into EEPROM, so inside the printer. And that was all a set of things. Sorry, go ahead.
Yeah, okay. So this was it was an embedded program, right? So it was, and this was the reason why you had to rewrite it to fit to a EEPROM, right? For the optimization purposes.
Yeah, it had been running on an x86 as a DOS, not Windows yet, so it's still DOS. But there's no DOS OS on that chip in the one room.
Yeah, sure.
And we had everything we needed. We needed to extract it out of DOS, but generate the code from fourth. So we wrote a utility that would basically, and this now exists on GitHub, it would take the fourth program and more or less boot it up to some particular point where you said take a snapshot and it would make a binary dump that had an initial entry point, was a .com file, and you just execute it, and it was a pre-compiled, ready to go. It was like an a.exe or a.out out of your file, right? And you could get back into the interactive fourth piece with the GUI and the IDE if you knew how to get it there, and it would be so you could get the laser printer's COM port to produce the GUI, and you could hack the laser printer internally straight up, or you could just have it run the laser printer as a laser printer and look for print jobs on the input.
Could you also play Star Trek on the printers? No, this was.
Well, I didn't have Star Trek written in fourth.
Okay, this is what.
But you could.
Yeah.
So that was go make a embedded system out of a DOS first setup environment. Output it in 68,000 instead of x86. There's a couple changes that went through that. Along that, we had a couple of fun things. One of them was you had 4 byte-wide EEPROMs till you get 32 bits because it was a hot new chip. 68,000 needed 32-bit input, so you had 4 EEPROMs. You had to run it through the tools to take your binary and split it into 4 paths and then burn 4 chips and then put them in the printer box. and you take the old 4 chips out, throw them under the UV lamp to go erase them, and then you pull out of the UV lamp box and put them in the programmer to print. And you swap the chips accidentally enough times that we finally got disgusted and wrote a little bootloader that said, given any random ordering of 4 chips, they give you random bytes ordering, they can execute, but they're kind of stupid. So you could arrange it that they would figure out what order they were supposed to be, that they were in. Then you'd run to some code that had been shuffled each of the 4 times 4, whatever, or 4 factorial, 20 odd combinations. And it would print, you've got the chips in the wrong order. And this is the order they should be. And then we got smarter yet and just take our entire binary and shuffle it according to what the chips said. So after you programmed, you could program the chips one after another. You could throw them in any order, and it would boot, and the first 100 bytes would figure out what the order was and what it should be, and then it would shuffle the rest of the binary into DRAM. It would load the EEPROM into DRAM, shuffle it accordingly, and then run out of DRAM with the correct order, and you have to get the chips in the right order. It burned a bunch of DRAM for that. There was a bunch of DRAM on the chip because you had to hold the printer image. So you couldn't handle really complicated images in this debug mode because it wouldn't have enough space. But that was great for debugging. And then, of course, when you went to manufacturing, they put the chips in the correct order, and then you could get rid of this hack. You could run it out of EEPROM instead of running out of DRAM. That was one interesting story. It's nothing to do with comprogramming. The other one was that the hardware guys were having an issue where their printer would, they run it overnight for testing, and in the morning they come in and look. Somewhere in the middle of the night, the printer would screw up and do really wavy bad prints. It had some nice square, perfect test images, page after page after page after page after page. Thousands of pages in, they got a stack of paper like this. You look, there's some spot where it's just like all fucked up, and it's screwed up for a while, and then it gets back to being correct again, and it's all good. And I was like, they were like, is it software, please? No, it's not. No way the software can do that. This has to be hardware. We could not figure it out. So one night, me and Paul Snow were hacking late, trying to get the software to handle the next thing, whatever. And the hardware guys were staying late, trying to sort this out. We were all yakking and talking, whatever. And the printers in the background were like chunk, 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 chunk. And we all heard it make a different sound. We run over and look, and it's like doing the weird print thing now. I was like, what the hell's going on? And the hardware guy's looking at it, and I'm looking at it. I look at the clock. It's right on at midnight. And then I saw the hand on the clock go backwards on the wall clock. And I remembered from my days at Texas A&M that the wall clocks for the school classes were all tied to induction motors, tied to the wall frequency. And that Texas A&M had its own power generator. And I talked to the power generator guys at some point about wall clocks and whatever is going on, because I'd seen this before. And they said, yeah, we have to put out so many 60 cycles in a day so all the clocks sync up. And at the end of the day, at midnight, every night, induction loads hit, and it slows the generator down, and the clocks are slower, or the generator's faster or slower than 60 hertz because of heavy loads hitting or not. So at the end of the day, we do a true up, and we add or subtract cycles by speeding or slowing the generator a little tiny bit until we add or collect 60 circuits so we get the same count in the day, and all the induction motors slow down or go backwards or screw around until they all line up at midnight. And then we go back to being normal, and we don't fool the clock. Well, here it was, the same thing. The city of Minneapolis was adjusting their clock frequency at midnight. Well, it turned out the laser printer had a phase lock loop to the clock frequency. And the lasers are shining at a mirror, and the mirror spinning phase lock looped at a perfect frequency based at 60 hertz. Well, right at midnight, the hertz went to 57, 56 hertz, then up to 75, where they screwed around a little bit, and then they got the right count. And sure enough, the mirror was spinning wrong, and you get a little wavy lines when the laser wasn't doing the right thing, and that was the bug.
This is actually a great bug. And it happened a few years ago in Europe. And what happened is that they got the power from a different country with different frequency. And then all the clocks, not all the clocks, some of the clocks in kitchens and so forth, they were no more accurate. And then what they did exactly what you said. They just made the generators spin faster. Not genau is precisely. I think the network was overloaded. So and therefore all the generators were slower. And then they make it faster again, and everything realigned. So it's very similar story to yours. I also found it fascinating, actually.
So I pointed that out to the hardware guy. He never heard of that. And then once he heard of it, it made a lot of sense. And then he's like, we're just going to put in a frequency generator on the board, and we'll solve this problem. We will not look at the UV or this old school easy tech. We'll just put a bridge to the 60 hertz power supply, and that's what we'll pull up. No, don't do that.
Yeah, I actually would never rely right on the frequency of yeah.
People did for years upon years upon years.
Okay.
You had electric motor clocks. Mm-hmm. They were induction motors. They were tied to the frequency. And until you had cheap, reliable electronics, quartz, crystal vibrations with the cheap enough to go into everything, until that happened, all them clocks, they were all induction motors. I got a motor from my dad from like the 1920s. Mm-hmm. It was one of these old induction motors, not a nice wood, rounded this, very, very old school. And if you plugged it in, they had a little tiny lopside, so it would always start the right way. But if you plugged it in and you pushed your finger on the big hand hard enough for a little bit, it would overcome its offset and then start timing in reverse direction. And then it would just run backwards at perfect synchronicity backwards.
Okay.
And you could read the clock with the mirror image because it was off perfectly backwards. But that motor didn't care which way. Once it got going, it was synced at 60 hertz as you went around. Fine.
So it rotated also 60 times per second, right? So it was also the speed of the motor.
Somebody would step through and spin it at that speed, and then they would just run through some gearing and bring it down to the clock speed.
Okay. Interesting. So what happened after your printer adventure? So you solved the problem?
Right.
So what was the next interesting project?
Yeah, well, I took a bunch of random little consulting jobs. Went back to Texas. There were fewer in the computer industry in Texas than other places, but I wanted to go get an advanced degree. I want to get a PhD because my dad had a PhD, so damn it, I was going to get a PhD. So I started down that path. By now, there was a computer science department at Texas A&M. I was an early student in it. I got a master's. And I was looking around. There was generally a discussion and a thought that I should go to a higher end school than Texas A&M for a PhD in computers. There were better schools for that. And so I went to Rice, sometimes called the Ivy League of the South. It's a really nice school. I went to the PhD program in computers, again, brand new. Mm-hmm. I got my PhD for doing, what is now the core guts of the Java virtual machine, how to do a fast optimizing compiler, is the big appendix on my PhD, but it was what got me famous. And my advisor wanted to have some math in there. So what I got signed off on for was math. And the math is combining, what these days are called monotonic analysis frameworks. I don't know what your audience will have on the tech side for compilers. So any compiler school, somewhere late undergrad, early grad, you'll get a monotone analysis frameworks class. It just happens.
Okay.
I showed that you can take any two such unrelated frameworks, and if they have some crossing function, some way to get information from one framework to the other, then there always exists a combined framework that has that is monotonically better than the sum of the two individuals. So a monotone analysis framework lets you analyze something, discover some facts, usually to the facts to produce better code. The optimizer then uses these facts and says, oh, this is complicated expression. It's just some fucking constant. Let me just put the constant there and get rid of the complicated expression, right? So they're very common in optimizing compilers. Mm-hmm. They're very common in dumb compilers, even at the trivial level. There's always an easy way to do something there. As soon as you want to do more than one of these things, my thesis was basically there is a combined version which is strictly better than running this one, then running that one, and then taking the facts from this one to go improve this one and run this one again, and taking anything new it discovers and running this one. You run to a fixed point, they're not discovering anything new. There's a combined version which is strictly better than those two run in any number of times back to back.
Is there a limit? Can we have as many levels as we like? So we can combine it again and it will be better again, right?
You have to have a different thing each time. If I combine A and B and I have an AB, the AB is as good as all the A's and all the B's, okay, but it's nothing to do with C, mm-hmm. and C is a new combination.
Okay.
This removes a phase ordering problem in compiler land. And so a lot of old school compilers have also always wrestled with phase ordering. it doesn't remove all phase ordering problems. It removes a set of phase ordering problems. In that it's always better to run the combined algorithm to run any of these other phases however many times you want. It doesn't matter what you do with them, how many times. No, just run this one once and be done. And that turned into a much faster compiler. It's part of getting a much faster compiler, which turns into the JIT and HotSpot that made Java go fast. So that was the connection to, where people started to figure out Cliff can do something on a more global scale, not just in pieces, parts of oil companies in Texas.
But when was it? Which year was it?
The thesis?
Yeah.
I was, let's see, mid 90s, early 90s.
Okay. Because Java happened later, right? So what was the connection between, your work?
Oh, yeah, did I miss a year in there? No. I went to 4 years, so like a year undergrad, then a year and a half at master's, went to Rice, 4 more years at Rice, getting the PhD, consulting gigs occasionally. I went to Motorola. No, which order did I do this? I went to HP Labs for a year and a half. Tried to talk them into doing this Cliff's new idea of how to do compilers, and they had a big old school compiler, and they weren't going to move very fast. And I did a bunch of fun things that were not terribly related, and moved on. Wife wanted to move back. I wanted to move back to Texas, so we went back to Texas. 2 years at Motorola. Fun stories there. Beating IBM on IBM hardware with my compiler. That was fun. Catching Intel cheating on benchmarks. Like, I couldn't make my generated code beat theirs, and on this one benchmark, back then it was Intel benchmark wars on chips. x86 faster or slower than PowerPC. Why? Well, I could beat the IBM compiler on a lot of benchmarks using my compiler. Oh, that's cool. We couldn't beat Intel on this one compiler. Like, what the hell's going on? So, dove in deeper and deeper, discovered that this one method, they're doing a thing that it looks funny to me. I can't make my compiler do that. Why not? And I stared a long time and said, that's not even right. You can't do that. So I'm looking at machine code generated by the compilers, the 2 different compilers, and finally sorted it down to, they did a thing which has to be illegal. Why are they doing it here or nowhere else? It'd just be busted all over the map if they're doing this everywhere. I decided maybe they were just looking at the method name. Sure enough, I could write a program that had this method name in it, that had this shape code, and they would do this transformation completely illegally. So I could just write a program that was, did something stupid and trivial, had the right method name, had the right in it. Oh, look, they would do this transformation. Oh, look, the program would just throw an assert afterwards saying, nope, I got the wrong answer. Your compiler has a bug in it. And then, I talked to my bosses at Motorola, and they went over to Intel and said, excuse me. And so Intel retracted a benchmark number, and suddenly I was beating Intel on Intel hardware with my compiler on Motorola hardware, and that was very fun.
It was quite an achievement because you were a one-man show, right, with your compiler?
No, they had a compiler at Motorola. No, I joined a team.
Okay. So
they had I say my compiler. They had a team of like 4 or 5 guys, pretty serious full-time compiler writers. I piled in. It wasn't the style that I had been advocating out of Rice yet. An old school compiler, but I knew about compilers. So I by this time, I'd been on the insides of several old school compilers that were these large monolithic things. And I had written all the appropriate passes for them at Rice and afterwards at other places. So, I knew my stuff. So
was it challenging for you? Or was it just fun? So, and you had 2 days a week, and the rest of the time you wrote Star Trek game.
Computer games? No, here's real jobs. These are real jobs.
Okay.
So I had to work, but the challenge changes to, can I make this go faster now? Can I beat some other guy? Can I? So that's the fun. The fun is rise to the occasion. We all know how to write compilers. Can I write one better than you and beat you? Right. So yeah, that was fun stuff. I got married. I had kids. Life was going on. Things were happening in life, but in the compiler science, I was continuously honing my compiler skills on an old school compiler that I did, the right things to go make it do good work. Another one that came out of there was the early discovery of the cost of iCaches and bloat, code generation bloat, like inline. Oh, the major optimization is inlining. Everyone has to inline to get a lot of performance. Everything until you hit iCache blowout. So that was a fun one where my knowledge of everything hardware stack, like I can't do chips directly. I can't write transistors, but I understand what level the hardware guys hand me very, very well.
Mm-hmm.
So we were staring at, what's going on with performance. And I had written some hack and it gave me a 5%, and then somebody else had done something and had not given them. And I looked at this, what the hell? And I changed something and I lost the 5%. And I changed something, I gained it. Like, what's going on here? So I finally started writing a binary search on optimized .o files. The make system would run the compiler and generate, the compiler itself, and the compiler would go run and build all these .os. And then I was like, what happened with my 5% come and go? And I did binary search on the optimizer or not on the .os and this one benchmark. And oh, look, it turned out to be the order of placement of the .os on the link line.
Mm-hmm.
And this one was compiled with -02 and this was compiled with -01. It was take this pile of guys, all .os. If you linked them with splat.o, you got one order.
Mm-hmm.
If you linked them with a named list, you got a different order.
Okay.
The order mattered more than -02 versus -01.
Mm-hmm.
Why the hell does the order on the
what
link
is
line matter?
-02-01? What is it?
Compiler optimizer levels.
Okay.
-02, take more effort, take more time,
Okay,
produce better.
I understand. Okay.
Yeah, okay. So it's actually better than -00 debug build
Mm-hmm.
versus -02, which is the best optimizer
Okay.
level. The link line mattered more. That placed where things landed in memory. Where the hell landing in memory matter for performance?
Mm-hmm.
Well, it turns out you got a four-way set associative iCache. You got four hot lines that happen to land to the same line in the iCache. They fight each other. They run out. iCache can't hold them all. Somebody's always get five. You get five. And a four-way associative, you can hold four. You get the fifth guy, he kicks one of the four out. Well, the fourth guy was hot because they're all five are pretty hot. So the fourth guy comes back in pretty soon. He kicks this guy out. Well, he kicks this guy out, who then kicks this guy, who kicks this guy. And round robin you go. They're always missing an iCache. And there's your performance.
Okay.
So
what is your relation of your work to Java? So you spent some time at Motorola.
Yeah, okay. So Motorola sharpening skills. Eventually, I got a call from Urs Witzel, who's now some bigwig at Google. I didn't know the guy from nothing. He was at Sun. He was I don't know, kind of a bigwig, either head of the HotSpot project or VP Eng at Sun or something. He was a guy at Sun. He knew his compiler stuff. He knew I'd been doing some good work. He read my thesis. He decided that the back of the thesis, the appendix, was how to write a fast optimizer. He's in the job of trying to get Sun's push for Java, which is Sun competing with Intel.
Mm-hmm.
So Java goals, write once, run anywhere, and you can run it on Sun chips or Intel chips. Well, I can't make Intel go away, but I can make it a no-brainer to move your code over.
Mm-hmm.
You don't get vendor lock-in on Intel if I can get you onto Java. You get vendor lock on Java, but Java's this public open standard. You can run on any chip you like. So let's get people onto Java and off from C, and then I can get them out of Intel-only land,
Mm-hmm.
right? So Urs is trying to make Java run fast. Java has this built-in concept of we're just going to generate code on the fly. There is an existing implementation. It's pretty weak. They know they can do better. They're trying to figure out how to do it. Sun's full of compiler engineers, but they're of the old school variety of big, heavyweight, monolithic compilers. Here's this hack this guy did where he's done a bunch of runtime compiler work already. He's got this cool concept of how to write a fast optimizer. He wrote it at Rice as part of my PhD program, but I couldn't get a PhD for that. I had to do math, fine. But it's all over his appendix in his PhD, how to do a fast optimizer. Let's give the guy a call. So I'm like, yeah, I can do that. I can go, I'm looking at your Java bytecode spec. I can go generate code for that. It's pretty straightforward. What do you want? And they were like, well, come out to California and go write this thing. And I'm like, well, okay, I can't live in California. I can't afford to buy a house in California. I need a down payment on the house. And they were like, because I got kids now. Like, okay, we'll give you a starting bonus that'll be down payment on the house. And then I was like, well, I have some buddies from college, from my grad school years that did this work with me, and they'd be really cool to work with, and they know what I'm doing. And they're like, oh, we got two more compile engineers that know what the hell they're doing. You want to come join? Yeah, sure. Sun was full of money, and they were hiring people as best they could. So Sun hired me to come out and write the JIT for Java. And, I came out to California and moved and got settled and couldn't believe the prices compared to housing prices in Texas, and took that giant leap of faith. Suddenly had a mortgage for a third of $1 million. Like, who'd ever heard such a thing? My house in Texas was 55,000.
Mm-hmm.
A nice, good starter home for a family with 2 kids, whatever. Now here I am owning a mortgage for almost a third of $1 million. Like, what the hell am I doing? But in hindsight, it worked out really great as a California, real estate market. So I went to Sun. I looked at what they were doing. They had a very simplistic, in my head, compiler that was based on, I want to say, the European style writing compilers. Sort of me completely being, racist, but Europeanist racist. What the hell is that one? It's what it's like academic flavored, high level, abstract, pass after pass kind of thing, where you gradually lowered it down to machine code. And I knew that was going to make shit for code.
One question regarding the compilers. You read research papers regarding compilers, or you just invented them on the fly, your approach? So it was like your approach, or you were interested in the work of other, compiler builders?
No. So I got a PhD in compilers at
Yeah.
Rice. So I read tons of compiler papers at Rice.
Okay.
So I knew all the historical, current academic, and a lot of experience papers. The main guy at the computer science department was big into Fortran parallel supercomputer work. So I knew all the Fortran optimization levels and how they bake down into machine code and why that.
Okay.
I had all the theories.
So it was his actual work, right? So you read a lot of stuff, and this is why you.
Yeah. So that was the understanding. While I was writing one of the early compilers at Rice, that was it was a class I took. Oh, go write a compiler for this stupid thing. It's a RISC-like fake blah blah blah. We eventually got a RISC, early IBM RISC chip that we were going to write code for as well. Whatever, fine. So we are busy writing compilers, and I was looking at the things I'm doing over and over and over again, and that symbology manipulation in my head is just running all the time. And I'm like, this pattern I've seen, I'm doing this again. What the hell's underlying going on here? And I did a transformation in my head where I mapped a classic control flow graph with basic blocks of tuples. I don't know what your compiler background for your audience is, but this is very old. And even LLVM to this day does this all the time. So it's a graph. It's a control flow graph. It has basic blocks. Basic block have a list of instructions. The hard part when you start doing optimization here is finding out where something's defined. Mm-hmm. I've got use. I want to find the definition. I want to change. I want to modify. I got to find all the uses and all the defs. They're not conveniently located near each other. I have to go hunt around. So you run these abstract data flow analyses to try to figure out reaching defs and last use and live rhythm, blah, 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 whatever. So SSA was a thing, was coming around as a discussion. And I was looking at how the hell static single assignment worked and this fee node concept. And then it suddenly, the thing flipped in my head and was like, a tuple is 2 arguments, typically an op, like an add, and a destination. And if I take this tuple as an op and I look at the destination, if I'm in static single assignment, that destination variable has the same one-to-one mapping to the instruction as a whole. So why do I need a destination variable? It's the instruction as a whole already. The instruction has a name. It's the pointer name. It's the pointer value. It's the address in memory. That's the name I need. I don't need another name. Mm-hmm. So drop the tuple from having 2 inputs, an op and an output, to just 2 inputs and an op, and the tuple itself is your output. Well, the input names also have to get renamed to a pointer, because I renamed the output variable name register 990, virtual register whatever, to the pointer, rename the inputs to the pointers as well. Suddenly I have op pointer, and it points to something else, which is an op pointer. I got a graph. I have pointers to nodes, to instructions, whatever. I have pointers. Mm-hmm. What can I do with a pile of pointers? Well, immediately from use to def, I have a pointer. It's direct. So I don't have to find the def if it's in static single assignment form. I just have it right in my hand. And from there, this became what's called the sea of nodes. I named it sea of nodes pretty quickly. I could do the same thing with control. Again, it's just a control flow graph. Well, I have another graph here. Why do I have two layers of graph? Can I make it one? Can I just move that line, that distinction? Sure enough, it was pretty easy to do. Suddenly I have a single layered graph it's just nodes pointing to nodes, pointing to nodes, and there's an opcode in pointers. And that turns out to be, it's the essence of the program boiled down to dependencies in SSA form, and it's extremely easy to manipulate now. That was the core for a faster optimizer. I said, from this, I can do all your normal analyses, but I can do all these other transforms on the graph directly that are extremely easy to do because it's a graph form and I have my uses and my defs all in hand. I don't have to go hunt for them. That's what Urs picked up on, I think. I don't know. He picked up on me somehow. So when I came back to Sun, Java, this was the compiler I wanted to write. I wanted to take the thing that I had done at Rice. I had messed with it at Motorola some, but they had their big old school compiler. And I had made a version of mine that was doing things, but it missed some of the major optimizations that the big old school compiler had that I could get to in spare time. But my job was to make the old school compiler go. So when I came to Sun, I said, okay, clean slate. Nothing they have really counts as a big old school compiler for Java. I can do a clean slate. I'm doing my thing I did from Rice. I'm going to make it happen for Java. And that worked out very, very well.
And the JIT came in JDK 117 or something, right? So it was the first time?
Yeah. There was a very early version. You had to ask for it. There was a private JIT. You could pick between the two. It was turned on by default, I think, in 1.3. So the early version would run some of the benchmarks that people were excited about and was showing good numbers there and certain kinds of easy things and had plenty of bugs. And so, you didn't want it on by default unless you tested really.
And you had, you read lots of research papers. You had, as a PhD student and compiler,
not lots of research papers. I read lots of research papers.
But
I wrote a few.
But you were, you had a hero, someone you say, okay, this guy is really incredible in compiler, or you just read it and you say, okay, everything is understandable. So you read so many papers. So was someone back then you say, okay, this is incredible what I read. So you were surprised, or was it just no reading and understanding? This is what interests me.
Yeah, there wasn't. There were a few people who I wanted to. Okay, so no hero like what you're asking per se. I kept looking for that person that I would consider a hero. And I kept finding people and looking at the work they had done, like, wow, this is really cool. And then I would talk to them and understand like the limits of what they had in their own head about what their work was. And that like deflated me. Like, this is not the guy that I want as my hero. And I never found that hero.
Okay.
But there were plenty of times when I had things like, I got told you can't do this. I had anti-heroes. And then I at some point I took some of those and like, of course I can. What the hell are you talking about? And the reverse challenge came up and I just said, well, here, I'll just do it. And then, my PhD thesis has one of the chapters has attacks on humbugs because somebody said, you can't do this. And I was like, of course I can.
So
I did it.
You mean you read the research papers? Okay, this is a great work, and then you met the person. You were disappointed because of what? Because you said, okay, this was.
No, I go ask for the next obvious thing. I read the paper. It opened up some new mapping of symbologies in my head. I would manipulate it. Wow, okay, I see. And and something happens. Okay, cool. And now you can take this and run with this new thing. So I go talk to them. Hey, how about this? How about this? How about this? Well, you can't do that. We tried. We could never make it work.
Okay.
What do you mean you can't make that work? Of course that works. It's just straight up extension of what you did. Like, no, you can't do that. And I'm like, yes, you can.
Okay.
So I did it.
And you enjoyed the work at Sun? So you like Sun? So the work environment and everything?
Two minds, right? I started to get to do the thing I wanted to do the most, which is write my kind of optimizing compiler on a real system.
Mm-hmm.
And early days at Sun, I kind of had a fair free hand, and I was producing and making it happen. And I got a lot of good feedback. I got to stand up in front of Java 1 crowds and talk. And
Which year was it? You remember?
The big year was probably 2002.
Mm-hmm.
Went to Java 1. I was going to present what I had been working on, which at this point was I was getting C-like performance out of Java code. If you wrote C-like Java code, you got C-like performance.
Mm-hmm.
I mean, it's easy enough in Java not to write C code, and you don't necessarily. But if you write C-like code, you get C-like performance.
Mm-hmm.
So I went to go talk about that. And it was all these Fortran array optimizations that I had been learning about at Rice that I was applying to Java. And you couldn't do them all. There's some things that were tough, but there were a lot of them you could do. Mm-hmm. And no one else in the JITting world had ever dreamed you could apply Fortran optimizations to Java code in a JIT.
Mm-hmm.
So, I was walking around Moscone Center, staring at the giant crowd, like 20,000 people, Moscone, whatever. And it's come time for my talk, and I'm going upstairs to go find the room. It's one of the top floor, whatever rooms, and street level rooms. And there's a giant mob in the lobby, and I can't hardly walk through, and I'm getting freaked out from my introvertedness. Like, holy crap. And I'm trying to push my way to the room, and it's getting thicker and thicker. And people are looking at me funny and giving me the evil eye because I'm cutting in line, except I'm not. I'm just trying to get to my room to talk. And finally, somebody says something to me, and I says, I need to get to that room. I'm the speaker. And they're like, oh. And then when I got to the room, everyone was trying to get in that room. It was a 350 person limit room. They had more than double that waiting in the lobby to get in. Like, what the hell did I do? So I gave that talk. They had so many people that they canceled the next speaker and let the people in the lobby in. And I gave the same talk again, back to back, another 350. And actually the fire marshal came through and were like letting the hit like 400, was like, no. You can't have more than this in here. There's too many. So they were, pushing all the boundaries. And then I gave that same talk a third time at the end of the conference. I found another spare room. And at that time, I actually had time to do Q&A. Like, the room was overpacked. So when I'm done, I got like max 5 minutes Q&A, and they had to shuffle. And of course, the room was overpacked. So it just took a long time to shuffle. So that was wild.
And you enjoyed that? Speaking?
Yeah. Gosh, somewhere at Texas A&M, I stood up in front of a group that was doing something to do with, I want to say embedded systems, computer, whatever. It was the double E side of things. And I was nervous as all hell and super scared and, public presentation, yada, yada. And somebody said, the usual tricks, like imagine everyone's naked in the crowd. That helps. It really does. Somebody said, you're the local expert on this topic. No one can ask you a question that it would be unfair for you to just punt and say, I don't know. Talk to me afterwards and we can go look it up.
Mm-hmm.
Right? If you're going to come with me with a question I can't answer, and I say I don't know, they don't know either.
Mm-hmm.
They don't know if it's an impossible question, a hard question, a trivial one I should know, but I don't because I'm faking it. Super imposter syndrome going on in my head. And in fact, imposter syndrome was with me for decades and decades. Only in the last 15, 20 years have I kind of gotten over imposter syndrome. I am what I am, and I'm like Popeye the Sailor Man. I am what I am. I am's what I am.
How long you work for Sun? So you just
Yeah. Okay. So I was there a grand total of I want to say 97 to 2003, 5 years or something,
mm-hmm.
of which 2 years to write the core JVM C2, 2 years to get it kind of
mm-hmm.
rock stable. And during that time, Sun management just went down the toilet. And the engineering experience for me personally went down the toilet. The development team didn't know how to handle me.
Mm-hmm.
If you look at the numbers, I was doing half of all new code in the compiler piece of things.
Mm-hmm.
Next guy down was doing half of the remaining code, except he was only doing technical debt cleanup.
Mm-hmm.
The next guy down was half of that. And so it went for 7 people at halvesies at each point.
Mm-hmm.
So, they didn't know what to do with me. I was deeply frustrated with the development team getting very more process oriented. So I played along with the process games. I reviewed every single putback, and it became more and more difficult to get people to do reviews for me, but they wanted to have a requirement that it get reviewed, but they would not review.
Mm-hmm.
So I couldn't get code put back. What the hell is an engineer whose entire lifeblood is producing and building something code-wise, not able to do pushbacks because people refusing to review your code? Because it was more code than they could ever write in any length of time. So they would only spend their time reviewing. That was how fast I was, and that's where I was at. So at some point in there, I sat down and did this experiment where I looked at more than 10,000 commits. And I categorized every commit as new work or tech debt cleanup or bug fix.
Mm-hmm.
Many bug fixes would not fix the root cause bug, but they would reveal the next layer to the bug. So sometimes you get bug fix on bug fix, but it was very, very rare that a bug fix itself was itself buggy. It just wasn't complete.
Mm-hmm.
And I split it up amongst the people. And I ran through and did the math. And one of the complaints I got was I wrote the most bugs. Well, it turns out that on a per line of code, I was spot average. I had a bell curve for the team of 7 people. I was spot average in the middle of bug per line of code
mm-hmm.
for new code. There was a separate bug rate for bug fixes on bugs and a separate bug rate for bug fixes introduced by tech debt cleanup. And they were lower. So like new code had a certain bug rate. Tech debt cleanup had half that rate. Bug fix for bugs was half again.
Mm-hmm.
It was a shorter drop. It was like 40, 50, like 10%. It wasn't 10, 20%
mm-hmm.
at each step. It was a pretty stiff drop. But new code had the most bug rate. I wrote the most new code by a lot.
Mm-hmm.
So I got the most bugs. It's true. But also, if you didn't write the new code, you didn't get the new features out.
Yeah, exactly.
There was a steady stream. Intel was introducing SSC chips, like the old FP stack thing was horrible. They had the new SSC chips. You wanted to have support there. They wanted to have new language features come in the language. They wanted to have optimizations for the new locking. Everyone was multi-core now. You had to have locking. The locks sucked, make them go better in the compiler, blah, blah, blah. There was an endless stream of new features. I was doing all of them.
What you did after Sun?
So as that got worse, and it became clear to me that the management was just making it impossible to do anything, and Sun was running downhill, and their upper management was fucked up, and
mm-hmm.
Sun chip couldn't compete with Intel, and Intel had cheated their way to faster, whatever.
Mm-hmm.
I got a call up from Azul System,
mm-hmm.
and Azul System said, "Custom hardware for doing Java. Come to the C2 Java port, HotSpot port." And I was like, "Fuck this! I'm out of here." And I jumped to Azul. And that was the most fun of my life. Custom, it was the best of times and the worst of times. Sun was drama. Azul was.
If you okay with it, I would like to stop now and.
Oh, I have to. Oh God, yes, I know how.
And re-invite you to talk about Azul, Java, and whatever you do now. A really interesting story. And I think we met once. And this was Java 1 or the server side, and you already worked for Azul. And what I remember is it was something with open source. And I'm coming from Java E or Jakarta E, so from the servers.
Open JDK?
Not JDK. You were JDK, but the topic was about open source. And I said, okay, I don't know what I said, but you became really angry. And you said, and then I say, why you're saying this? And then I understood you're coming, from the JDK perspective, and my perspective was from the server. So what you thought, and this is why I say, okay, I know you from somewhere, and this was either a Java one later, so you attended. This was like a Q&A session with Sun, I guess, still, and you wanted to have something more open source than it was. And my argument was the opposite, but not about, JDK rather than Glassfish or server or something like that. And last question, maybe. Do you actually like Java, the programming language? Do you like that? Or you said, okay, this is just, toy language. I just, optimize it to get a job. Or you actually like the Java programming language. So what was your opinion back then?
Back then, the goal of write once, run anywhere was awesome, and I loved it. and I totally ran for save the world. Everyone needs this thing.
Oh, very good.
Yeah, totally. I horrible with money, didn't know how to ask, didn't ever get priced right, underpaid forever, and also save the world. These days, I enjoy the Java programming experience because the tool chains are so awesome.
Yeah. Okay, thank you. So,
yeah,
I would really like to reinvite you back. It was a lot of fun for me, and
sure.
and talk Azul and later Java. And thank you for coming. And see you next time.
And send me a link to where this podcast hits. I want to see it.
Yeah, not see it here. So we're not recording the video. It's just. Last question: where people can find you on the internet? So you have some, links or.
I have a very stale cliffc.org, cliffc.org website. These days, I'm on Discord at Running Coffee Compiler Club and on YouTube at @compilers, YouTube/@compilers. You'll see a bunch of chats like we're doing now with a weekly group of compiler geeks that's been running for like 3 years.
Oh, perfect.
Or on the Discord that you have to be compiler gearhead and then go there. And then socially, I have a LinkedIn page, it's stale. I have a Facebook page, it's stale.
Okay.
I don't do these things. Again, I have a Twitter account, actually. It's actually not actually stale. I do check the Twitter account on a regular basis.
Okay, thank you.
Yep. Thank you.